Reversible reactions. What are reversible reactions? The reaction in which the reactant can form a product, or a product can decompose and form back the reactant. These type of reactions are known as reversible reactions. So reactant can form a product, the product can decompose, and it can form back the reactant again. For this reversible reaction, we define a term equilibrium. What is the meaning of equilibrium? The term equilibrium means when rate of forward reaction means when reactants are forming a product, that's called a forward reaction. So rate of the forward reaction is equals to rate of backward reaction and there is no change in concentration or amount of reactant and product. So when reactants are forming a product, we call that as a forward reaction. And when the product decompose and form back the reactant, that's known as reversible reaction. So reactant forming a product, this is a forward reaction. Product decompose and form back the reactant, that's a backward reaction. So how we define the term equilibrium? Equilibrium means when rate of forward is equal to rate of backward and there is no change in concentration. And for reversible reactions, you will have some reactant and you will also have some product. But the term equilibrium means when their rates are also equal. Example, if we have a reaction in which we have reactant which form the product and some of the product is decomposing, forming back the reactant. So example, if we have 2 grams of reactant and we have 5 grams of the product. So what happened if out of 2 grams, 1 gram of a reactant is forming a product and at the same time 1 gram of a product is forming back the reactant? Is there any change in the amount of reactant in product? Like example, you have 2 grams of reactant and you have 5 grams of product, but out of 2 grams, 1 gram of a reactant is forming a product and at the same time 1 gram of a product is forming back the reactant. Is there any change in amount of reactant and product? So there will be no change in amount of reactant and product. So as there is no change in the amount of reactant and product, what we call this state? We call this state as equilibrium. So this is the meaning of equilibrium or a balance for a reversible reaction. When reactant form the same amount of reactant forming a product and the product decompose the same amount forming back the reactant again. So there is no change in amount of reactant and product and we call that as equilibrium or a balance. But example, if you have reactant are forming a product, if 2 gram of reactant is forming a product and 1 gram of a product is forming back the reactant, is it in equilibrium, this reaction? Because reversible reaction can be equilibrium, may not be in equilibrium. Is this reversible reaction in equilibrium? 2 grams of reactant are forming a product and 1 gram of a product decomposed to form back the reactant. So this is not in equilibrium or a balance. So reversible reaction may be in equilibrium, may not be in equilibrium. If it is not in equilibrium, then there are two possibilities. First, copy this part, then I will explain the two possibilities. Copy this part first, so I will move on. This is about the reversible reaction in which the reactant can form a product. A product can decompose and form back the reactant. We define a term equilibrium. Equilibrium means when the rate, the speeds of forward and backward reactions are same. Yes, finish writing this.
Sir, please 2 minutes, sir.
Okay.
I just.
Equilibrium. So, what are the possibilities for a reversible reaction? So, reversible reaction, maybe it is in equilibrium or it may not be in equilibrium. Equilibrium or dynamic equilibrium, you can also use the term. It's the same thing. So if it is in equilibrium, there is no change in concentration, either for reactant and product, and the rate of forward is equals to rate of backward. And I just gave the example, if you have reactants is forming a product, a product can decompose and form back the reactant. But both occur at the same rate, same speed. Example, if originally you was having 10 grams of say reactant and you have say 7 grams of a product. But what happened out of 10, if 2 grams is forming a product, at the same time 2 gram of a product will form back the reactant. So what is the overall change in amount of reactant and product? There is no change in amount of reactant and product. We call this as equilibrium or balance. But second possibility, a reversible reaction may not be in equilibrium. So if it is not in equilibrium, there will be a change in concentration of reactant product as well as the rate of forward is not equal to rate or speed of backward. So how we represent this? We represent that is not equal. And then it has two possibilities. Maybe the forward rate is faster, or we can say equilibrium shifted right. These are the terms which are used. If forward rate is faster, we can use the term equilibrium is shifted towards right. Or maybe the backward rate is faster. If backward rate is faster, we can use the term equilibrium shifted to left hand side. So example, we have reactant and product. For a reversible reaction. So example, 3 grams of reactant are forming a product, and out of 3 change, only 1 gram of a product is forming back the reactant. Is it in equilibrium? This one, when 3 grams of reactant form a product, but only out of this 1 gram of a product decompose to form back the reactant. Is it not? It is not in equilibrium. If it is not in equilibrium, so which side it is faster? It is forward or right hand side it is faster. So we will use the term equilibrium shifted to the right hand side. If the forward rate is faster, it means equilibrium shifted towards right hand side. And opposite, as we have reactant and product, so reactants forming a product can decompose. But what we observe if 2 grams of reactant are forming a product and 5 grams of a product is forming back the reactant, so which rate is this is not in equilibrium because the speeds are not same for forward and backward. So which rate is faster? The backward is faster. So if backward rate is faster, we also say equilibrium shifted towards left hand side. And if equilibrium shifted towards right hand side, it means the percentage of the product or amount of product increase or yield will increase. Or we can also say the yield will increase. But if it is equilibrium shifted towards left hand side, so what we will say? We will say that the yield or the amount of a product will decrease. Is it clear? So copy this part. So there are factors which affect the reversible reaction. Position of equilibrium. So the 3 factors which affects the position of equilibrium. Number 1, the first factor is a concentration or amount. or amount of reactant or product added or removed. The second factor which affects the position of equilibrium is the temperature. And the third factor, the only three factors affects the equilibrium, and the third factor is the pressure. So these are the three factors which affects the position of equilibrium or switch the position of equilibrium. First one, the first factor will discuss effect of concentration. Adding or removing reactant or product. So example for first one, if I'm adding reactant, okay, so A and B are the reactants here, for example, A plus B, and this was forming a product, say C and D. Initially, because initially in the beginning we consider it is in equilibrium and we are finding the effect. What will be the effect if we change the concentration? Like we were having 10 grams of reactant and we were having 15 grams of a product, and out of 10, 1 gram of a reactant is forming a product. At the same time, 1 gram of a product is forming back the reactant. So means that was in equilibrium or balance. If I add reactant, the first adding or removing a reactant or product. So if we are adding a reactant, example, now we are adding, we have 10 grams of reactant first in the beginning. But now what we did 20 grams of reactant. We made 20 grams. So how the equilibrium will be affected? So which one you think, which one will be faster, forward or backward? If you use more reactant, which reaction will occur at a faster rate? The forward reaction or a backward?
Backward.
The forward reaction, the rate of a forward reaction increase. Why the rate of forward reaction increase? You can see here, look, 10 grams of a reactant decompose, like out of 10 gram, 1 gram decompose and form a product. At the same time, 15 gram of a product is there. Out of this 15, 1 gram is forming back the reactant. So this is equilibrium. But what happened? We add a reactant. If I add a reactant, I made 20 gram. So if 10 gram was forming 1 gram of a product, so 20 grams will form how much? The 20 grams will form 2 grams, because more reactant means more product will be there. So if 10 grams is forming 1 gram of a product, then 20 grams of a reactant will form 2 grams of a product. And still we have a reactant 15 gram, which will make 1 gram of a product. So which reaction is faster here? Which one occur at a faster rate or a greater rate? So forward reaction occur at a faster or a greater rate. So whenever we add a reactant or adding a reactant, what it means, it will shift the equilibrium towards right, or you can also say forward. This is always the effect. Whenever we add a reactant, addition of the reactant always shift the equilibrium towards right hand side. If I add more reactant, I will get more product. So forward reaction will be faster, and in comparison, backward reaction will be slower. That's why we call equilibrium, or the balance of this reaction is shifted towards right hand side. Is this clear? The effect of adding or removing. The first part is adding reactant. copy this one, if no doubt. So effect of adding or removing reactant or product. The first one is if we are adding a reactant. Now what will happen if we, the second part of this, if we remove the reactant. So we have, for a reversible reaction, we have both reactant and product. The reactants are forming a product and the product is decomposing, forming back the reactant. So example, I'm taking the same example. If we have 10 grams of the reactant and we have say 15 grams of a product, and out of 10, 1 gram is forming a product. At the same time, 1 gram of a product, out of 15, 1 gram decompose and form back the reactant. So this is equilibrium or balance. Now what we are doing, we are removing the reactant. We reduce the amount of reactant. So if I decrease the amount of reactant, what will happen to equilibrium? Like I was having 10 gram, now I made 5 grams of reactant. So what will happen to equilibrium? Where you think it will shift? If I reduce the amount of reactant. So if I reduce the amount of reactant, it will shift backward. How it shifts backward? You can see out of 10, 1 gram is forming a product. So out of 5, because it is half, so it's only 0.5 grams will form a product. But and still it is 15. So 1 gram is forming a reactant. So rate of forward is slower because you reduce the amount of reactant, and the backward is faster. So whenever we remove the reactant, what will happen? The equilibrium shifted towards left hand side or backward. So this is the effect of removing the reactant from a reaction mixture, because in a reversible reaction you have so reactants are forming a product and product decompose, form back the reactant. But as you reduce the amount of reactant, the forward reaction is slower and the backward is faster. That's why you say equilibrium is shifted towards left hand side, because which side is faster? That's a shifting of equilibrium. This is a state when it was in equilibrium. But the second case, we remove the reactant, so equilibrium shifted towards left hand side. Then if we add reactant, sorry, if we add product, like if we increase greater amount of product, So first the reaction is in equilibrium. You have reactant are forming a product, and the product is decomposing, forming back the reactant. First, originally it is an equilibrium example. The reason why I'm using the same number so that you understand the ratio as well easily. So example 10 gram and 15 gram is there. 1 gram out of 10, 1 gram is forming a product, and out of 15, 1 gram is decomposing, forming back the reactant. If I add product, I increase the amount of product. It is 15, I made it 30 grams. What will happen? Where the equilibrium will shift? Towards right or towards left? If I increase the amount of a product, I add more product, I increase the amount of product, where the equilibrium will shift? It will shift towards left or backward. Why? Because look, 10 grams of reactant is there, so this 10 gram will produce same 1 gram. But it was originally 15, now we made double. So if 15 out of 15, 1 gram is forming a reactant, but out of 30, 2 grams will form back the reactant. So adding a product where the equilibrium will shift, it will shift the equilibrium towards left or backward. And the last one, if we remove product, so where the equilibrium will shift, example, the same reaction I'm taking. So I have 10 grams, but I remove the product. I was having.
Sir, how can you add a product?
The reaction mixtures are there, like example, nitrogen and hydrogen react and form ammonia. Ammonia is a product. So from any other source, if we add ammonia to the reaction mixture, the equilibrium will shift towards left-hand side. From any other reaction or any other source, we are adding a product. So same way, if we have 10 grams of reactant, but if we remove the product, out of 15, I have 7.5. So 10 grams, 1 gram is forming a product, but out of 15, 1 gram was forming a product. So out of 7.5, only half will form the, sorry, here we have 15 gram of a product, so 1 gram is forming a reactant. So if I decrease the amount of a product, I made 7.5, so this will be 0.5. So what it shows that equilibrium is shifted towards right hand side or forward. So these are the factors which affect, like the forward is faster and the backward is slower. So we call that equilibrium shifted towards right hand side or forward. So these are the effect of concentration changing the amount of either reactant or product. So factor affecting equilibrium when we change the amount of reactant or product. Is it clear?